the magic. So we're going to take radicals, and much like in the review, we're going to look for three things. One, oh, I don't need that. One, is it a perfect square? Two, is it not a perfect square, but its factors possess perfect squares? Or is it three, not a perfect square and no perfect square factors? So can't be simplified. So when we have 245, wowzers. All right, 245. So when we think of perfect square factors, we think of the first sets of perfect squares. Well, square root of 1 is a perfect square, but that doesn't get us anywhere. So remember, we're looking at square root of 4, square root of 9, 16, 25, 36, 49, 64, 81, 100, 121, 144, 169, 196, and 225. Those are the first 15, and all but the square root of 1 will benefit us. So 245, well, 25 doesn't go into it. That would be my first thinking. So nothing comes to mind immediately. So what we can also do, the other technique that you can utilize, not only looking at perfect square factors, but if we break that down and do the prime factorization of 245, well, 5 goes into this 4 times, and 5 goes into 45 9 times. So just finding the prime factorizations sometimes helps me, or the factors, helps me find that perfect square factor. So doing that was very beneficial because the square root of 49 is a perfect square. So we got 7 rad 5. So those are two really good techniques in order to figure out how to simplify a radical. 320, well, I know 4 goes into 32. So rad 4, rad 80. So this becomes 2 rad 80. And I'm going to simplify 80 is 4 times 20. So 2 times 2 times rad 20. And rad 20 can be broken into rad 4, rad 5. So we get 2 times 2 times 2 times rad 5, which gives us 8 rad 5. Rad 216, n to the 5th. We're going to first separate each one into their own radical. Remember, when we deal with radicals, what gets rid of a square root? A square. I have some gregarious students who are watching as I make this video. So if we can find a square inside of that radical, it will cancel with the square root outside. So 216, what are we going to break that up into? 6, 7, 8, 9. So when I add the digits of the number, I know that 9 goes into it because the sum of its digits are divisible by 9. That's the 9 rule, divisibility rule. And 9 goes into 216, 2, 18, what's that, 36, 24? Come on, pen, stay with me. Nope, dead. Pen died. That gives me 3. 4 goes into 24 6 times, so that's 3 times 2 rad 6, or 6 rad 6. Now n to the 5th. So we're going to break this into n squares. That's 4 and that's 5. So this would give me an n. It will cancel, come out. That gives me an n, and this one stays in the house. So that's n squared rad n squared rad n. So I'm going to take the outside things with the outside, 6n squared, and then I'm going to combine the insides. So we get 6n squared rad 6n. Ooh, that is so good. All right. Rad 700 m to the third. We're going to separate each one into their own radical. 700, well, I'm going to break that into 100 times rad 7. That gives me 10 rad 7. M to the third, I'm going to break that into m squared rad m. That gives me m rad m. Outsides are 10m. Insides are 7m. 10m rad 7m. Ooh, so this is our first one with a coefficient. And 225 is a perfect square. That's 15. Remember, there's the benefits of being able to remember your perfect squares up to 15. And 9 times 15, I don't know. 40, hello, 45 and 135. I think that equals 135. So you can get a whole number sometimes. Coefficient is -9, 162. I'm going to break that into 62, 9. Back at 9 again. 9 goes 1 times. That's 72, which is 8. So rad 9 times 3, 18 is 9 times 2. So we get -9 times 3 times 3 times rad 2, which is -9 times 9 rad 2, which is -81 rad 2. I don't take the square root of -81 for 2 reasons. The most important reason is there's no radical around it, outside it. So we leave it as -81. We have 5 rad 16 times rad a to the third. 16 is a perfect square. A to the third, I'm going to break into a squared a. And we get 5 times 4 times a times rad a, or 20a rad a. Number 8, a lot of 8s in number 8. 8 times, what's that, 16 times 5? We're not going to go the 4 route. Yes, 16 times 5 times v to the third, which will make v squared v. And that's 8 times 4 times rad 5 times v times rad v. That's 32v rad 5v. And you should at this point be this efficient, this easy. So here we go. Let's try this one again, please. Thank you. Eraser. Whoop. All right. We have like terms here. How do we know we have like terms? Because they have the same radical. Much like variables, when we see 2x plus 3x, these are like terms because they have the same variable to the same exponent. When that happens, we combine their coefficients. So that would produce 5x. So we have like terms here. They're like terms because they have the same radical. And so we're going to combine their coefficients. The coefficient is -1 and -3. It's a little tricky because that negative sign represents a -1. So -1 and -3 makes -4 rad 3. We keep the radical. We're adding and subtracting. That radical does not come out. We are not playing the matching game because we only play the matching game when we are multiplying. Shh. They don't know you're listening. They don't know you're here. There's a gaggle of kids here watching, measuring me, waiting for me to make a mistake. Again, we have like radicals. Because we have like radicals, we can combine their coefficients. Coefficients of this problem, of these radicals, are 3 and 3. So that gives me 6 rad 5. Very, very simple, super fun. Now we have 3 terms. Our first term is 2 rad 2. Our next term is -2 rad 6. And our third term is -1 rad 6. So which ones are like terms? The ones with the rad 6s. So we're going to combine their coefficients. negative 2 and negative 1. This 2 rad 2 just comes along for the ride, and we end up with negative 3 rad 6. Now, something that I didn't point out with the other first two is make sure that your radical is simplified. Remember the three things. Every time we see a radical, we're looking to see, is it a perfect square? If it's not a perfect square, does it have a perfect square factor? Or is it already simplified? So in these cases, these two radicals, rad 2 and rad 6, are simplified. So we can't break that down any further. We have like terms again with the rad 5s, which makes negative 4 rad 5 plus 2 rad 2. The order, there is no standard form with radicals. I'll accept either way. If you gave me 2 rad 2 minus 4 rad 5, I'd accept that. Either one is fine. Number 13, we have like terms. That gives me negative 6 rad 2 minus 3 rad 3. As easy and as fast as that. So here's where, that's too bad. All right, so I was going to say the rad 8 needed to be simplified, but we look at their coefficients, 3 and negative 3. So they're going to cancel out, and you're just going to be left with 2 rad 2. So we did not have to do anything with that, but be careful of those. Again, notice the transition. We're transitioning from adding and subtracting like terms to multiplying. And when we multiply, we do not want to create rad 80. Yes, rad 8 times rad 10 does give us rad 80. We can put radicals under the same, we can put individual radicals under the same radical when they're multiplying. We can't do it when they're adding and subtracting, but when we multiply, rad 8 times rad 10 does make rad 80, but then we would break it down. So that's very inefficient. Since we have these radicals broken down already, we're going to break them down even more. We're looking to match. So I'm going to make this rad 4 rad 2. I'm going to make this rad 2 rad 5. The reason being is I'm going to look to see if I can match up two radicals. Rad 2 times rad 2 equals 2. And our thinking is we have rad 2 squared. And remember, what gets rid of a square root is a square. So if we can write a radical as a square of itself, it will cancel out that radical and give me that base. So this is a match. We also have another nice little Easter egg since it's Easter season. We also have a perfect square. So this gets simplified to 2 times rad 5. Square root of 4 is 2. Rad 2 times rad 2 is 2. And then you have your rad 5 that doesn't get simplified any further, and that gives us 4 rad 5. Rad 14 and 28. I'm going to keep rad 14 as rad 14 because I'm going to break that 28 into rad 14 times 2. I found a match. That gives me 14 rad 2. That's the nice, efficient way. We're always looking, how can I match? So 17, we start with coefficients. So we're going to multiply the outsides times the outsides. 6 times negative 6 is negative 36. And then we have the radicals, 56 and 3. 56. 8? What's that? 8 and 7? No, that's 54. Well, let's take half of it. Mr. Max Brain, 2 and 28. Yeah, 4. No, yeah, 3 is not going to go in there. Okay, but it does have a 2 and 14. Yeah, 2 and 7. So we could do 4 times 14. And why'd I pick 4? Because that's a perfect square. So I'm going to break 56 into 4 times 14 times rad 3. Mr. Mac is making a mess of this at the moment. Yeah. There you go. That's nothing wrong with that. Negative 36 times 2. and then we're going to multiply these two because they have no common factors that we can use to match up. So 14 is 2, and that's 42, rad 42. Yep. So 36 times 2 is 72, rad 42. Ooh, is that ugly? That was very uncomfortable. I did not feel like did not feel very confident with that answer, which is okay. It happens. Sometimes some problems you feel good about, some problems you question a little bit more. So we're going to do 2 times 8, which are on the outside, and then rad 24 and rad 3. Rad 24 is broken into rad 3 and rad 8. The reason why I did that is because I'm going to match this 3 with this other 3. So that provides me 16 times 3. I got the 3 from the match, and then rad 8. Well, rad 8, we should be able to see that we can break that down. So that's where students tend to make their mistake, is they forgot to simplify a radical. So that's 16 times 3 is 1848 times 2 is 96 rad 2. Now you're noticing I'm doing a lot of this in my head. So that's good and bad. Good because I should be exercising my brain. Bad because I'm not checking my work. So if I do it in my head, I'm most likely going to be making a silly mistake. In 19, we're going to start distributing. So we're going to distribute this rad 21 into the 2 terms, rad 5 and rad 7. So we're going to look to see, can we match it up? 21 has no radicals anywhere. This is great. You all are getting a really good video today.
I'm so sorry.
You're not sorry at all. It's all good. You want to call out some names? You want me to call them out?
Evan,
There you go.
Bradley,
All right.
Ariana, and John.
Perfect. Vision and hearing screening, just in case anybody's... Thank you.
Thank you.
So there are no factors that can cancel or match, should we say. So we're just going to have to multiply those two together. Let's go, slowpokes. Skedaddle. That gives me rad 105, which feels like we could simplify that, but you cannot. And then rad 21, we can break that up into rad 3, rad 7, and that's going to match with that other rad 7 that is being distributed. So we have rad 105 plus 7 rad 3. Again, the order doesn't matter. And was that your one?
No.
Okay. Way before? Okay. Here we have rad 6 times rad 6 plus rad 6 times 7. Rad 6 times rad 6, we love. The 6 comes out. And we have to be cognizant of this. This is a radical in. This is outside. So this produces 7 rad 6. Order, I'm not too particular about at this point. Number 21, now we have some coefficients that we're distributing out to each of the terms also. So I really want to see that first line. I want to show that distribution. I want to see you write that line. Now we're going to multiply. This is my first multiplication. I'm multiplying these two numbers. So I'm going to multiply the outsides. 2 and 3 make 6. And now we have the radicals. So I have rad 5 times rad 5, rad 3. I broke that 15 into 5 and 3 so I can match up. So that's 6 times 5 times rad 3, or 30 rad 3. Now I have my other two numbers that I'm multiplying. And again, that's outside and that's outside. So I'm going to multiply those. And that's 2 times 3 times rad 5, or 6 rad 5, 6 rad 5. So my answer is 30 rad 3 plus 6 rad 5. Number 22, negative 8 rad 15 times 2 rad 3 minus 8 rad 15 times 3 rad 14. That negative sign, there needs to be a sign in between these two products. That's a product. This is a product. This sign is determined by what we're distributing right there. So we have outsides, -8 and +2 is -16. Now we're multiplying these radicals. I'm going to see if there's a match. There is. I'm going to break 15 into rad 3, rad 5, and these match up. -16 times 3 rad 5. Now I'm going to multiply these two numbers. -8 and +3 gives me -24. And I have rad 15, rad 14. No common factors. I got to multiply 14 times 15, 26, 5, 1, 0, 11, 210. Rad 210. You should be able to multiply two-digit numbers that quickly. If you're not well versed at that, you need to do some practicing. Again, 210 feels like we can simplify that, but we know we can't because there's no common factors in 15 and 14. Factors of 15, 1, 15, 2, no, 3, and 5. That's it. Factors of 14, 1, 14, 2, and 7. There's no common. So there's no need for us to break those up. We know that we're just going to have to multiply and make it a product. And there are no perfect square factors or no matching terms. So -16 times 3 is 1848, -48 rad 5, and -24 rad 210. How ugly of a problem was that? That was pretty ugly. We can check also at the end here whether I did it correctly, but we're on number 23. Now we move to division. So there's lots of different ways to tackle this problem, and we'll do all three. One of them is you can take this and we can play the matching game in the sense of breaking rad 20 into rad 5, rad 4, but the matching this time is numerator and denominator. Rad 5 over rad 5 produces a 1. So that would give me 1 over rad 4 or 1 over 2. That's one technique we can do. You can also put them under the same house. Much like multiplication, how I said that you can put them together under the same house. If we're multiplying, we can also do that as in division. So we get 1/4. And now we can separate rad 1 over rad 4. Square root of 1 is 1. Square root of 4 is 2. We also get 1/2. That's really the easiest, best way. We could continue to do it some more interesting ways. Yeah, come on. Get some more. Grab them all.
Almost done.
Rad 5, rad 20. Rad 20. Here's another way that we can do this. I'm not going to rationalize this because that's not going to be efficient. Excuse me, be respectful. Let's see the other technique that I used. All right, that way we didn't. We're not going to rationalize this. I'll use the rationalizing technique later when it's more relevant. So we have rad 24, rad 49, rad 24, and rad 49. If I put them under the same house, we can't simplify. They don't have a common factor, 49. So that doesn't benefit us. But we should see that rad 24 can be broken into rad 4, rad 6, and that rad 49 is a perfect square. So we get 2 rad 6 over 7. And that's it. That can't be simplified any further. It's rational because there's no rads in the denom. So that is really what we're doing with this problem. 25, again, these are great questions. These are, oh man, every single one I didn't have to rationalize. All right. So 5 rad 32 is rad 16 times rad 2. We have 4 times rad 49, which is 7. So we get 5 times 4 rad 2 over 28. excuse me, let's do this. This was not very efficient. We have 4 times 7. So let's cancel the 4s. That's much more efficient. So that gives me 5 rad 2 over 7. That's the best way to do that problem. 5 rad 36 over 6 rad 64. Again, perfect squares. This is not fun. We can cancel the 6's, and this gives us 5 over 8. If we don't rationalize any of these, I'm going to be very disappointed. Yes. Ask and you shall receive. All right. So rad 7 can't be broken down. Rad 6 can't be broken down, but we can't. So neither of those radicals, that's that third type of radical, none of them can be simplified. So what do? We can't leave this answer because we have a radical in the denominator. A radical and a square root, like rad 6, if we do 6 square root, we get this irrational number. A number that is irrational is non-repeating. There's no pattern. 4, 4, 9, 4, 8, 9, 7, 4, 2, 7, 8, 3, 1, 7, 8, blah, blah, blah. It never repeats. So irrational is non-repeating and non-terminating. Non-terminating means it never ends. So we can't have an irrational number in a fraction in the denominator. So we have no rads in the denom. So what gets rid of a square root of 6? Well, another square root of 6, because that would be square root of 6 quantity squared. And the square would cancel with the square root, and that would leave us with 6. But it needs to be an equivalent fraction. We're producing equivalencies. So when we can't just multiply it by rad 6, we have to multiply it by a value of 1. So what would the value of 1 would be a rad 6 in the numerator. Rad 6 over rad 6 is equal to 1. So we're not changing the value of this original fraction. We're just changing the facade. And that gives me rad 42, which cannot be simplified because there are no common factors in 7 and 6. So that is my correct answer. We have rad 4 over rad 7. Let's simplify first. Can I leave that as an answer? No, I need to rationalize. Can't have a rad in the denom. So I'm going to rationalize it by multiplying it by rad 7 over rad 7, which gives me 2 rad 7 over 7. These 7's cannot be canceled because one's in the radical and one is outside of the radical. So those are not like. I cannot simplify that. First thing I'm going to do, this is a simple one, I'm going to cancel those. I mean, what else is going to happen during this thing? Hello. I love that. I don't have the, I never had the program. I'm sure, I think Diana might. Yeah. Yeah, I would not do an hour. And let's set the, yeah, I know, but it has been, I mean, I thought Way of the Cross was a little too long from start. Yeah, I know, right? Exactly. Okay. Yeah, sorry I couldn't answer it. Yep. All right. Thanks. Bye. One of the best. Yeah, go. I mean, this video is going to be one of the best videos ever. I'm making a video right now. You're on it. You'll get, yep. All the proceeds will be donated. Yep.
Emily, Cody, James, Lorenzo, Emerson, Jack, and Elizabeth.
There you go. The best video ever. One of my longest ones, maybe too, with the least amount of, oh Lord, with no sustenance. No, yes, no, you're not bugging at all. All right, let's take a peek at this one. So I'm going to look, I see a common factor here. So there's a couple things. I see a 3 in there. Not 9, Mr. Max, 6. And so we have rad 3, rad 7. So 7 times 3 is 21. 3 times 6 is 18. So those rad 3's can cancel. Now we have rad 6 over rad 7. Can't leave it, so I have to rationalize it. And we've seen this answer already. Rad 42 over 7 would be my final answer. 8 and 4, I'm going to simplify those coefficients. 2 goes into 8, 2 goes into 4. Excuse me, 4 goes into 8 twice, 4 goes into 4 once. And then we have rad 14 and rad 21. So I have 2. I'm going to break 14 into rad 7, rad 2. The 1 in rad 21 I'm going to break into rad 7, rad 3. I'm going to cancel those radicals out. And that leaves me with 2 rad 2 over rad 3. Don't make that mistake. I almost popped it out. I cannot leave that. I got to rationalize it. Rad 3 gives me 2 rad 6 over 3. I'm multiplying radical times radical. Outsides with outsides. And that can't be simplified. And that's it. Oh, there it is. Look at that. Yes. Did I remember negative? Let's go check number 22. 22. 22. Did both of them have negatives? Yes. I think I got a perfect score. Yes. All right. That's it. All the craziness. Have fun. Good luck. Come and see me if you have questions.